Welcome to this lesson on the Introduction to Blockchain Development with Ethereum presented by Coding Bootcamps. This is Ethereum Basics. A little bit about our instructor. Jim Sullivan is a senior blockchain instructor and developer at DC Webmakers. As a software engineer with 18 years of experience, Jim leads an expert team of blockchain developers. Also is an expert in DevOps, cloud, application development, and the safe agile methodology. Jim is also an expert in blockchain platforms like Hyperledger, Ethereum, Corda, and also multi-chain and EOS. These are some recommended prerequisites. However, these are not required prerequisites. So, Ethereum is a global open source, fully distributed peer-to-peer computer network. And here is its website. So Ethereum can be thought of as an operating network. And that if it sounds like operating system, well, there is an analogy there. Just like an operating system can run several applications, an operating network can also run many or numerous applications. On Ethereum, users can write applications called decentralized applications, or dApps, that will transact or take action on digital currency called Ether. And the full network will be able to always run that application. And it is immutable on the Ethereum network. And Ether is Ethereum's native token. Before getting to the Ethereum network, let's discuss blockchain. So I guess you could say blockchain is a data repository, and we're going to avoid the term database for right now. Although a database and the blockchain have elements in common in that they are repositories of data, we will look at blockchain as storing records of transactions. So the way that a blockchain actually stores the data is in the form of a ledger, a digital ledger. So it tracks ownership of assets and it tracks changes of ownership in those assets. So records are only added to a blockchain, just like with a ledger. So any removals or changes in the ownership status or fractions of it are entered as a negative change in ownership. And then there's also positive changes in ownership. Balances can always be calculated. So a blockchain is quite scalable. So it is very scalable, has a unique construction, and it has key properties of security and immutability. So it is because of particularly these two attributes that blockchain is ideal for exchanging assets between two or more users without the involvement of trusted third parties. So until blockchain transactions, with few exceptions, always involved a third party to act as a trusted intermediary. And that third party ensures that the transactors receive their assets and that everybody gets paid. Trusted third parties is a service, and that service costs. And the involvement of a trusted third party also involves time. So anytime we purchase something with a credit card, we may notice that there are pending transactions or the transactions have not been completed yet. We make a deposit and that transaction has not been validated or completed yet. So that's the time. That's that some trusted third party is behind the scenes updating ledgers. Blockchain has the ability to allow transactors to directly update the ledgers peer-to-peer, and that lowers the cost and the time of the transaction. The first blockchain assets were cryptocurrency. It's agreed upon that the first modern blockchain applications was Bitcoin. So Bitcoin runs on a blockchain. So yes, it is the Bitcoin application that runs on the blockchain infrastructure. So the two are not the same, although there's a common misperception that Bitcoin and blockchain are the same thing. It's a similar analogy in the way that Google and Yahoo are applications that run on the internet. Obviously, Google and Yahoo are not the internet, although sometimes it seems that way. The internet is Google's and Yahoo's runtime environment. On a blockchain network, users or transactors conduct traditional commerce and agree on prices for items that they are buying and selling. On, say, Bitcoin, users send and receive digital Bitcoins between one another. So transactions on the Bitcoin network are limited to the Bitcoin native token. In other words, Bitcoins change ownership on the Bitcoin ledger, and the changing balances are reflected in each user's Bitcoin wallet. And once the transactions are completed, they are permanent records on the Bitcoin blockchain. And as a result of the Bitcoin application's success, it's been innovated, and there has been progress relative to blockchain. So we can consider Bitcoin's blockchain as a first-generation blockchain. Ethereum is a second-generation blockchain. Most experts define the first-generation blockchains as blockchains that only manage or only transact their own native token. So there's no distributed applications. There are no custom assets. Whereas second-generation blockchains not only manage their own native token, they can manage any type of asset, and they can also run applications called smart contracts. So the emergence of second-generation blockchains have caused us to think about the way assets can be traded. Ethereum and other second-generation blockchains have made it possible to exchange any type of asset, as well as important information on the blockchain. So we can tokenize information. We can tokenize user attention. Here, we hear a lot now about voting. So we can exchange votes, information for votes. So electors or the public can send their vote assets to candidates on a blockchain. That part is not hard. Most developers can have that part up and running in a few. The hard part is validating who indeed is doing the voting. Blockchains such as Ethereum make it possible to model assets on a blockchain. So just like with Java or C++, we can model real-world objects. We can do the same thing on the Ethereum network. So we can exchange assets. We can model an automobile. Its VIN, its color, its make, its model, its year. Assets generally come in two varieties, tangible and intangible. So a tangible asset is something physical that we can touch, hence the name. So things like precious metals, homes, buildings, computers, laptops, phones. Intangible assets are things like an IOU, or a patent, or a copyright, or a trademark, or even computer files. Both tangible and intangible assets can be transacted on a blockchain, and we can use Ethereum for that. An asset is an entity of value, so that's that is the definition. Accountants say that assets are entities that result in positive cash flows for the owner. Money, property, these are all examples of assets. Ethereum and other blockchains run on a distributed network. So the developers of Ethereum came over from Bitcoin. They were all Bitcoin developers, and they took that concept of the distributed network over to Ethereum. This form of the network ensures the blockchain is always up and running and is less vulnerable to attack. Here is a centralized network with the central focal point. All nodes on this network communicate, but they communicate through the central focal point. If anyone wanted to attack this network, they can attack the central focal point. That brings the whole network down. You see here a decentralized network has several central focal points. Every node here can communicate with another node. However, they must communicate through a central focal point, and then the central focal points communicate. So this is somewhat less vulnerable to attack, but it still has can still be vulnerable at the focal points. Distributed networks, especially with Ethereum, where all the nodes are peers, exactly equal, if any of these nodes would go offline, another node can step in and take its place. If one or more nodes came under attack, those nodes can temporarily be removed from the network. And as soon as new nodes come back on, the data, the most recent data, can be copied to those nodes. So it is high resiliency and less vulnerable to attack. So in what we talked about here in this lesson is the Ethereum structure, the Ethereum basics, and the blockchain architecture. Here is an assessment. And here are some additional resources. For additional resources, please consult your learning materials. And for additional training, please consult your learning materials. The next session is first and second generation blockchains. Thank you.